Hey guys, today we're going to talk about something called a transversal. And transversals, they are in reference to now, instead of dealing with one or two lines, it's going to be having three lines and a special relationship that starts to develop there. If you're following along with the slides, we'll start right at that first slide. There's some definitions. So a transversal, let's say we have two lines, N and M. And they could be parallel, they don't have to be parallel. Turns out something really special happens when they are parallel, but let's just say they're not parallel for now. But we're still going to focus on the space of the lines where they don't intersect yet. So they're going to clearly intersect somewhere up here, but let's just say we have these two lines for now, N and M. The transversal, we call a transversal a third line that comes through and intersects our two lines that we already have. So line K would be a transversal for line N and M. Now there's a lot of special things that go on with transversals. One of the first things we want to do is just be able to recognize specific groups of angles and specific pairs. So first group we're going to look at is, well, we'll look at these four angles here that I've marked off in red, little red dots. These four angles, we call them interior angles. So if you look at the two lines we started with, N and M, when K came through, it formed four angles over here, four angles over here. It formed 8 angles in total. These four angles are the angles that are between the two lines that were intersected. So N and M were the lines intersected by K, and the angles that were formed, that line between those two lines, we call them interior angles. So I'm going to mark them off. These four angles are interior angles. Now if you look at the other four angles that are left, those are the angles that are outside or not between N and M. So these four are the angles on the outside. We call them exterior angles. So the angles that lie between the two lines that were intersected, those are the interior angles. The angles that lie on the outside, we call them exterior angles. Now when it comes to interior and exteriors, if we just focus on interiors first, we'll put little numbers next to them. There also are some special pairs within those groups. So one special pair, we call these alternate interior angles. So it's a pair of angles that are interior and they're on opposite sides of the transversal, like 1 and 4. Your transversal is K, so on opposite sides, they're like diagonally across. So angle 1 and angle 4, we call them alternate interior angles. They're on opposite sides, but 2 and 3 are also another pair. So angle 1 and angle 4, and also the pair of angle 2 and angle 3, these are called alternate interior angles. Alternate interior. So 1 and 4 and 2 and 3. And a very similar thing happens with the exteriors. So angles that are on the outside of those two lines that were intersected and on opposite sides of the transversal. So we'll number these 5, 6, 7, and 8. So angle 5 and angle 8, those are opposite of one another. These are called alternate exterior angles. So angle 5 and angle 8, and also angle 6 and angle 7. Angle 6 and angle 7, we call these alternate exterior angles. So those are special pairs that we're going to see within our interiors and our exteriors. Now there's also one other type of angle, another special type of pair, and we're moving on to slide 3 now. And for this, we'll use the same two lines, N and M, and we'll still be intersected by the same transversal, K. And these last angles we call corresponding angles. So when we look at the transversal, we see that it creates 4 angles at line M, or line N, and then it creates 4 more angles at line M. So in total it creates 8 angles. if you look at the placement of the angles, like angle 1 is in the top left, angle 2 is in the top right, angle 4 is in the bottom right, angle 3 is in the bottom left, in relation to line N with the transversal K. Corresponding angles are angles that are in the same position, but just at the other line. So like angle 1 corresponds with angle 5. They're both in the top right. So it's another special type of pair. Angle 1 and angle 5. Angle 2 would go with angle 6. They would correspond with one another. Angle 3 corresponds with angle 7. They're both in the bottom left in relation to where that transversal intersects the line. So angle 3 goes with angle 7. And angle 4, the bottom right, goes with angle 8 here. And again, we call these corresponding angles. And they're just another special type of pair, and we'll go into more detail with them in the future. So we're going to do one little practice problem together, and then I'm going to be a lot of practice on your own. Right now, it's really just about knowing all these special relationships. I know there's a lot of them, so it's about knowing the special relationships and being able to point them out. So the problem that we have, slide 4, we have these two lines. These are your two lines being intersected by this line here. We'll call them L, M, and N. So here, line L is your transversal. And M and N are going to be the two lines being intersected. And we have 1, 2, angle 3, and angle 4, angle 5, angle 6, angle 7, and angle 8. Alright, and the first thing we want to do is name 4 pairs of corresponding angles. So our 4 pairs of corresponding angles, well, let's say we start with angle 1. Angle 1 corresponds with, well, it's in the top left over here, so we're going to go to where the other line is, line N, find the angle in the top left. Angle 1 corresponds with angle 5. These are going to be our corresponding. Angle 2, well, that's in the top right over here, so let's go to the other line. In the top right would be angle 6. So angle 2 corresponds with angle 6. Then angle 3 goes in the bottom right. That's going to correspond with angle 7 here. Angle 3 and angle 7. And then angle 4 corresponds with angle 8. Angle 4 and angle 8. This is another pair of corresponding angles. Our next goal is to name 4 pairs of vertical angles. So we're still going to look for vertical angles. So vertical angles. So one pair we should notice here, angle 1 and angle 3. That's one pair. At that same point of intersection, we have angle 2 and angle 4. Those are vertical. Angle 5 is vertical with angle 7. And angle 6 is vertical with angle 8. So those are our vertical angles here. Our next goal is to name 2 pairs of two pairs of alternate interior angles. So alternate interior angles, we need to be interior. So to be interior angles, we need to be between these two lines. So our interior angles are 3, 4, 5, and 6. And our alternate interior angles, well, they need to be interior and on opposite sides of the transversal, so that would be like 6 and 4. So angle 4 and angle 6. And then also 5 and 3 are alternate interior angles. Angle 5 and angle 3. Alright, and the last goal is to name 2 pairs of alternate exterior angles. So alternate exterior angles. So to be alternate exterior, well, you have to be exterior. So that would be 1, 2, 8, and 7. And you have to be on opposite sides of that transversal. So L was the transversal here. So angle 1 would go with angle 7. Angle 1 and angle 7. Angle 2 would go opposite with angle 8. So there's another pair of alternate exterior angles. Alright, and that's all we have for today. Again, right now it's all about just knowing the relationships, which angles go together, and being able to set up different pairs of alternate interiors, alternate exteriors, corresponding vertical angles, things like that. Alright guys, have a nice day.